Okay, we can start. Can you hear me well? Okay. So I'm Luis Carvalho. I'm from Boston University. And let me talk a little bit about myself before we start talking about my incursions using Lua into my favorite editor and a database. So I've been a Lua user since 2003, right after Lua 5.0 came out. And I'm mostly using Lua for numeric applications, scientific computing. And so this is sort of a hobby sorts. That's why I decided to put integrating Lua for fun and profit, especially the Vim port was mostly for fun. So let's talk a little bit about this. So I assume that all of you know what Vim is, I think, right? So it's the best editor out there, right? And PostgreSQL is just a database. I assume that you all know what this is as well, so I won't be talking about them that much. So let me just give you an overview for why I decided to use Lua for this. At the risk of preaching to the core here, Lua, first of all, is a joy to integrate, right? It's very easy. First of all, it was designed to be embedded, and it's designed to extend some interface, some programs. So it's really a joy to program as well. There's even no need to mention the other features of Lua, right? The speed, power, it's very powerful semantically and has a lot of nice facilities, coroutines, and so on, tail recursion, and so on. It's flexible and enables us to achieve very high productivity. So the speed here is not only the execution speed, execution time, but also development time, right? We saw this many times in many talks here. Sandboxing is somehow straightforward when needed, and I will need it when I discuss the interface for PostgreSQL. And my sandboxing for PostgreSQL is not the hardcore sandboxing that you usually need when you have to cap time and keep track of other things. It's mostly I just need to create some suitable environment, so I don't have a lot of concerns in this regard. Lua allows for very tight integration. I think that's one of the major selling points of Lua when you decide to use it to extend some specific interface, and that's one of the main points that I will try to reiterate here. That's the main advantage of using Lua here. So it allows us to have like native types. We can have interface modules, and you can have a very rich semantics that somehow you can make the semantics that you derive in your interface to be very close to the usual semantics that is used on the host, in this case, either the editor or the database. So the two extensions that we'll be focusing here will be Vim, the text editor, and PostgreSQL, the database. And before I have these questions at the end and so on, I just wanted to remind you that Lua is very easy to port. So all the two extensions that I'll be talking here about, I have ports of them for Lua 5.1, Lua 5.2, and for Lua JIT. Okay? So you can use Lua JIT in both extensions. The license is very open source license. Vim has a charityware type of license, which is very similar to the MIT license, and the extension for PostgreSQL is MIT license, just like Lua itself. So let's start with Vim. Okay, so the idea here is that Lua is an interface language in Vim. So what does that mean? So recently, I think about 2 or 3 years ago, a number of languages were ported to Vim because I think that people weren't very happy with Vim script, which is the language that people use to, if you want to extend Vim somehow, to add more functionalities to the editor. And the thing is that we don't have, if you are an interface language of Vim, you don't have all the fine-tuning, the fine control that you can have if you use, let's say, Scite, if you use Lua and Scite. You cannot control all the menus and everything. And you have some limited interface to Vim, but that is powerful enough. The only catch here is that, so this has been since Lua Vim 7.3. The thing that you have to keep in mind is that the editor takes care of all the events. So if you want to control, I want to map a Lua function to like some specific keystroke, that's fine, but you have to use a Vim function for that, and that Vim function will call a Lua function. So that's what the interface means. Okay, any event has to go through Vim. That is, the interface is meant to be mixed with Vim script. If you want to create a Lua function that you want to call all the time, if you want to create some kind of library or something, that has to be done in Vim script. And inside your Vim code, then you can call Lua code. So you can embed Lua code inside Vim script. So that's the catch. There are two versions of this. There's a static and a dynamic linked version. That is, you can compile your Vim, and you can have you can put a plus Lua feature to it. But if you don't have Lua installed in your system, that's fine. The editor will just complain saying I can't find Lua. So it's completely fine if you have a dynamic version. All native Vim types are supported. I think that the Lua port for Vim is one of the most complete ports. I think that only Lua and the Python port they're fairly complete. And we have all of them. I'll go over the main types, and you see what I mean by all Vim types and what I mean by feature complete. I just wanted to mention here that there's one very nice application of this interface is the Lua Inspect Vim by Peter Odding. So Peter came up with a Lexer, and using this script, for instance, you can come up with, you can have things like you can parse your script, and then you can realize when you have locals you can have errors on the variable names, and you can say, oh, this is local, it should be global, and so on and so forth. It's only possible if you have the Lexer, right? So you can do that. So how does it work? So it's basically an interface. We need a bridge between Lua and Vim. So let me start with the easier part, which is Lua to Vim. So there are basically 4 functions that you can call in Vim to execute Lua code. The first one, the main one, is just there's a Lua command. So we add 4 commands to Vim. One is Lua, and you just say Lua and then the chunk, and it executes the chunk. So very easy, very straightforward. The next one is Lua do, and you can come up with the body of a function. And what happens is that, I don't know if you can see it well, probably not, but you can create, when you do Lua do body, it's a function, and then it has 2 arguments, line and the line number, and then you can do some body, which is some body of the function, and that specific function gets called and executed for every line of the current buffer. Okay. The other one is Lua file, which just runs and executes the file that you input as a parameter. And the last one is Lua eval, which basically allows you to return results from Lua. It's like a bridge from the Lua world, your Lua state, back to Vim. Okay. And it's semantic equivalent to this expression. So I get a chunk to be compiled. I put like a header on the chunk so that you can have an argument. And then it compiles and executes that chunk with the argument. Let me give you some examples because it's easier this way. So the very simple thing you can do is just use Lua, right? So you can just do Lua and then print something, let's say, right? So that's the most basic thing. And if you see those columns here, I don't know if you're so familiar with Vim, this is basically a command that you can run on the editor itself. I think I can actually, let me see if I can come up with a terminal. If I can come up with it. Here is, let me see. Is it big enough? Okay, here it is. It'll probably get truncated, so let me see here. So this is Vim. And I can type commands here. You can see there the column, right? So you can type commands. I can say, well, I can Lua, and then I can say, what is this version of Lua? And then it will return some command to me. So you can run any Lua command that you want. It will compile the chunk and it will execute it. If you have, let's say, a bunch of lines, here you can say, well, let's say just a line. Right? And then you can say, well, Lua do, let's say, print the length of the line. And then you say 0 and 11, let's say. So it goes over each line of the buffer and does things, right? You can return things as well. You can say Lua do, let's say, return line reverse, right? And you just reverse all the strings in the buffer and so on and so forth, right? So you have all those 4 types of commands that you can use. So that's the main one. You can have Lua file, and that % means the current file in the buffer. You can just say Lua file %, and it just executes the current file that you're editing. You can do Lua do, right, return line reverse, as the example I gave you. That is, for each line of the current buffer, it will execute some Lua function, and it can replace the current line in the buffer if you want. And you can use, let's say, LPAG if you want. You can just come up with Lua, and you say require LPAG. And then you can say, well, you can declare some grammar that matches, that's the balanced parenthesis grammar, and then you can just do Lua do to check if each line of your buffer is balanced with respect to parentheses and so on and so forth. So you can do a lot of things. You can do Lua eval. For instance, there is no pi constant in Vim, and if you want that, if you need that value, you can just say, well, give me, math.pi in Lua, and it'll just return that to you. You can print that, and so on and so forth. I have a more complicated example here that generates a random number so that you can see how Lua eval is used, but let's skip that. Okay? So the idea here is that A will be the arguments, and then you can use the arguments, and so on. So what about the types in Vim? So that's the basic Lua to Vim bridge. What about the other way around? What about Vim to Lua? So how can we use the things in Vim from Vim world from the Lua side? So there are two main commands for doing that. It's the vim.command and vim.eval. So Vim, in this case, you can think of Vim as a static module that is loaded automatically when you run Vim, right? When you run Vim, if Lua is present, then the Lua state is created, and inside that state, a Vim package is automatically installed. It's like a static package. So we have vim.command, vim.eval, it evaluates a Vim expression. I'll give you examples, really short. In Vim, it is possible to specify a range and run a command only on that specific range, not in the whole file. If you have a range and you specify a Lua command, then when you run it, then you have two variables, Vim first line, vim.first line, and vim.last line that stores these values for the range. And let me go back here to my example. So for instance, suppose that this is the buffer I have, and suppose that I'm running something on those 3 lines, right? I select the 3 lines. Then I can say, well, run Lua, and then just print, let's say, the value for the first line and the value for the last line. And it should print 4 and 6, right? Because those are the lines in my range, and so on and so forth. There is Vim line for the current line. You can obtain a current line, and there is some other functions for other objects. In Vim, there are basically 5 main types of objects. You can have the buffer, which is the buffer that we're editing. You can have the window. The window can have, you can have more than one buffer with different files and so on. And you can have, let's say, internal objects, which are lists, dicts, and funcrefs. Funcrefs are like functions. Okay? So those are managed using the usual type meta table setup, using the registry, just like LuaL, get meta table, set meta table, and so on and so forth. I also put this function, it's an extra facility, vim.type, so that you know what type of that is. I mean, it's for Lua, though they are all user data, right? It doesn't matter. They're all user data. It's a buffer, a window, a list, and so on and so forth. But if you want to do something, and if you want to check if it's a list, you can just use vim.type the object, and it will return list, dict, and so on. The semantics that we try to achieve here, we try for it to be as close as possible to Vim. So if you have, let's say, a list, then Vim has 2 functions. Let's say list add an element, and then basically this appends the element to the list. There's another function, insert, which basically takes an element and puts the element at any position. And usually this position is 0, that is, you prepend the element to the list. Of course, they're redundant, right? I mean, you can always insert at the end of the list, but we decided to keep them anyway, just to keep the semantic as close as possible. But on the other hand, there's a function len, list, in Vim that returns the length of the list. And in this case, we decided to use just the length operator in Lua. So you can just put hash, then list, and returns the length. So for other objects, it's pretty much straightforward. I try to avoid getters and setters. If you have a window, you have the line in the column where the cursor is in the window. Instead of putting, let's say, window get line or get column or set line or set column, you can just use index and new index, right? So you just have a win.line, which you can just use that to read the current line, the current cursor line. And you can set win.line to be whatever you want, if you want to set it. Buff name, next, and so on and so forth. So here are some quick examples. In this case, I'm just running the Vim command, set the text width to be 60. You can do that in Lua, right, directly. You just straightforward bridge. If you want, you can declare more complicated functions by using this construction here. You say Lua, and then you put this, and put end of file, and then you just type your Lua code, and then you finish it with the end of file. Okay. And here in this case, it's a range, right? It's defined from 3 to 4. So I will only execute this Lua code on the 3rd and the 4th line, the buffer. And in this case, you just delete all the lines in the buffer, right? I'll just go from the last to the first and just delete. I'll set to nil the ith line on the buffer. This returns the current buffer. Another quick example, it's a more evolved one. This basically centers the text, right? So you just take the whole text on the buffer, and then I take the buffer, I evaluate what is the line width, the text width, right? I use vim eval to get the value for this variable here. And then for every line in the buffer, what I do is I compute d, the left and the right offset, and then I center and I put padded spaces, right? I put some spaces in the left and the right, and then I return the new line on the buffer as some left padded spaces, the line, and then some right spaces, and that's it. So the list, the dicts, the buffers, and the windows are just box pointers. Very, very simple, straightforward. There's nothing else there. It's just box pointers. And the main advantage of doing that is that for list, dicts, and func refs, we have referential transparency. That is, if I have a list in Vim, and I modify that object in the Lua side, then the changes are capped. So there's no translation between, let's say, a list to a Lua table and vice versa. Then we translate a Lua table back to a Vim list and so on and so forth. It used to be that way, but then there was like some very subtle bugs. And then I decided to do it this way, and it's much better. I think Python now does it this way as well. By the way, func refs are new. They're not yet on the if Lua that is out there, the most stable version. I submitted a patch, but Brams, which is the creator of Vim, has a very long to-do list, so it's in the back of the list. But if you want a patch, you can get it, and you can have func refs as well. So objects have fixed lookup using index and uindex. So I don't use a table. I just look at the name of the method, and I just do a string matching. And if it's, adds something, I just use it. The interface is fixed. That's why I decided to do it this way. No getters or setters. Func refs are there mostly for efficiency and convenience, so that you can avoid if you know that you want to run a Vim function many, many times, then it's very costly to call vim eval and then the function all the time. So instead of that, you can create a func ref, which is a reference to a Vim function, and just import that to Lua, and then just use that func ref. So it's much faster. The func refs are a little bit trickier. It's not a box pointer. You need to carry some extra information. You have to carry the arguments of the function. In Vim, there is something called a self-dict type of func ref. That is, it's kind of an ad hoc object orientation that they have for dictionaries, where you can create a function and you can provide some extra argument to the function saying dict. And then if the dict creates one of the entries of the dictionary as a func ref, then you can use the self, basically a keyword, and define operations on the dict itself. This was very hard to get correct. And we are never sure if it is correct, actually, right? But it was very tricky to get it to work nicely with the Vim, mostly because of garbage collection. So Vim uses a reference counting type of garbage collector, and you have to keep track of the counts. So you have this dance, right? Whenever you create a list in Vim, and then you import it into Lua, when you create an object that references that list, you have to increase the counter. When you garbage collect your reference in Lua, you have to decrease the counter for the list in Vim and so on and so forth. So you have to be a little bit careful. Here are some quick examples. Here I'm intentionally mixing Vim code with Lua code. So this list here is created in Vim, right? You just create a list with 2 items, one an item. And then in Lua, I just evaluate from Vim L. So this L in Lua, it's a user data that points to the same list in Vim, L. And then in Lua, you can say, well, add a new list, and then set the 0 value to be pi, and then insert something else, true. And then if you do an echo L in Vim, then you recall this list, right? So it's updated in place. So there are no copies involved. Everything is just a reference. Similarly for dicts, you can have just a dictionary with n, a field n with value 10, and then you import that into Lua using vim.eval. They're the same dictionary. Then I say, well, in Vim I say let d self equals d, and then in Lua I say dx equals pi, and then if you echo d, then you have self, which was set in Vim, but then I have this value here, x, which is the value pi, and this was set in Lua, right? So there's this referential transparency. You can also do things like this. So this is a very quick example of using a func ref. So in Vim, there's this function tr, which is similar to the tr on the shell, right? the command, you provide a string, then I want to substitute the angles here by curly brackets, and you would have this tag. So this is run in Lua. I just take the tr function in Vim, and I import into Lua using vim.funcref. So I have a funcref to something, and then I just execute it. And here I have a more complicated example using this kind here. So this function here has this dict declaration, so it can be used as a self field on a dictionary. Okay, so that works nicely as well. So what about Postgres? So it's another interesting interface. Now Lua is coded as a procedural language. You know, the databases use SQL. SQL is not procedural. That is, you cannot have for loops and things like this. So in Postgres, they decided to come up with a number of procedural languages that would provide these kind of facilities, right? Recursions, for loops, and so on and so forth. They maintain 3 official procedural languages, which is PL Perl, PL Python, and PL-PGP SQL, which is like it's an extension of SQL. And then there are a number of other procedural languages. I decided to use Lua because I love to code in Lua, and it's much better than coding in Python, and it's more efficient and so on. So this is for actually work that I was doing with PostgreSQL. So there are 2 flavors for the procedural language. You can have a trusted procedural language, or you can have an untrusted procedural language. This has been since PostgreSQL 8.2. Now PostgreSQL is in version 9.2. I think this is since 2006, I guess. For the trusted version, well, you have to. It's basically a light sandboxing. There's no debug, no I/O. Very restricted OS, right? You can only have OS date, time. You cannot access files. You cannot do anything. You cannot run os.exit, something like this. There's no package or require. You cannot import libraries if you're using the trusted version. But if you really want it to be trusted, there is this facility where you have a plua.init table in the system in which you can put the modules that you allow to be required if you want to. So if you're just the system administrator of the database, and you only want your users to run trusted Lua code, but they want to run LPAG, let's say, then that's fine. You just put LPAG in that table, plua.init, and they can use it. The global table is aliased to a variable called shared, and that's mostly for, how can I say, tradition. If you look at PL Perl, they also have a shared table. If you look at Python, they also have a shared global variable. And access is restricted through set shared. So you cannot just go to the trusted function and just randomly write to global variables. If you want to explicitly write to a global variable, you have to use set shared. Inline statements are also allowed. That is, you don't need to create a SQL function if you just want to run some Lua code. You can just do and then run your Lua code, and that's fine as well. Server-side programming is also supported. So you have plans, cursors, triggers, you name it. We won't be talking about these here because they're mostly for PostgreSQL. So think of plans as prepared statements. You can prepare a statement, and you can substitute arguments and run them and so on and so forth. Allocations are in an exclusive memory context. That's how PostgreSQL manages memory. Basically, they don't have garbage collection like in Vim. But what they do is when you create your function, and specifically if you create an extension like a procedural language, you can create a separate memory pool that they call a context. And then all your allocations are done there. And then when you're done with the function that you want to call, or when you close the database, then that's just erased. You just collect and free all the memory pool. So there's a native representation for most types. I think that's one of the main reasons for the good performance of this procedural language, because if you take PL Perl, PL Python, what happens is that when they want to, let's say, import an array or a more complex type, that specific type gets converted to a string, and then they use that string in the Perl or Python or whatever, and then after they return that, the string gets converted back to the type. So we don't do that here in Lua. The only conversion that is done is if you have arrays or composite types, then they are converted to tables and back. But if you have a double, float, anything, they're converted to native types in Lua, and vice versa. We make a very heavy use of Lua's registry. The memory context, the type and function infos There's a lot of bookkeeping, basically. Type and data meta tables, trigger tables, Lua threads. We'll be using Lua threads for set returning functions. So there's a very heavy use of the registry. So let me give you some idea of how this is basically done. There is a PL Lua function. It's defined this way. So you create a function as you would in SQL, right? So you say, well, create this function named func with arguments args returning some type s, and then you put this, and then you put the body of your function, right? And then you specify the language. In our case, we can either do PL Lua, if it's the trusted version, or PL Lua U, which is the untrusted version, and that's it. So this body here, which is a Lua function body, basically what happens is that when this gets compiled on the PostgreSQL, what happens is that we compile a chunk in Lua, which is this. So we parse this, and we get the function name, we get the arguments, we get the return type, and what happens is that we keep track of what is the return type, what is the type of the arguments, and we compile this function. We use the same name as the function that was defined here. We use the arguments, the same arguments, and then we call the function body. The same function body here is called here. And we return the function, and then that gets called all the time, every time, right? There is one thing to notice here is that I put this local declaration here in the beginning, and this has two purposes. One is you can use this U here as an up value, right? Because func is a closure on U. So you can use this U to initialize some specific table. Suppose you want a cache, or you want a counter, or you want something, you can use this up value to do this bookkeeping for you. The other point is that you can make func also be recursive, right? Because we have local func, and then you can have func, and then you can call it recursively. So it's very nice for this. We expect these args to be named arguments. So when you create a func, you say, well, argument A is int, argument B is double, precision, and so on and so forth. If one of them is not named, so no problems. We just treat this as a var arg in Lua, the 3 dots. And let me give you some examples. So in this case, I'm creating a new type called greeting that has two fields. One is how, both fields are texts, how and who. And then I created the following Lua function. This function takes a greeting, just this type that I created, and some text, and it returns another text. And in Lua, what happens is that I'm just formatting f, which is this second argument here, using g, how, and g, who. That is the two components of the greeting type. Right? So here's one example. If I say select, greet, and then I say this is a greeting type, right? It has a how and a who. So how is hello, and who is Lua workshop. And this is the formatting string as the second argument here, f. And then it returns this, right? It formats, it takes the how, comma, the who, and it formats according to this. Puts an exclamation mark at the end. Here's another slightly more complicated example. Suppose I want a counter that every time I call it, it returns a counter, basically, right? So in this case, I put here in the comments so that we can remember that what we're doing is we are declaring a local variable u, which is an up value to the closure that is counter. And what is happening is all the time I'm just running a function that is wrapping in a coroutine, right? So I just increase u. U is the counter. I'm increasing it every time, and then I'm yielding the new value for u. And then after that, I can use the trick in which, the way in which I define a function, this end here ends the function, right? The function body. And then after the function is defined, I can do some initialization. I can say, well, u is 0. And then I can say, well, counter, it's actually a function, which is a coroutine wrap of the actual counter that was defined here. So if I do it this way, every time I call counter, I'll be getting 1, and the next time 2, next time 3, and so on and so forth. Just using coroutines. So set return functions are fine, again, thanks to coroutines. So I can just do some function called, let's say, greeting set. That takes how as text, and then who as an array of texts. And then it returns a set of greetings. And the Lua code is basically, well, take all names into this pair. So this array here gets converted to a Lua table, and then for every name in this table, I just yield a greeting, which is how and who with the name from this table, right? With the ith entry here. So here's one example. If I say, well, select do a greet with greeting set using this formatting. Remember greet from the last slide. And greeting set is just this call here. It takes hello. It takes an array with Lua Workshop 2012. And for each one of these entries, Lua, this function will create a new greeting, right? Which is put together by this yield here, in this table, which will be hello Lua, let's say. And then hello Lua is greeted by returning hello Lua and so on and so forth. Okay? So set returning functions are fine thanks to coroutines. Recursive functions are also fine. So here's a more complicated example that computes the log factorial of something using memoization and so on. In this case, U is just a cache. It's just a table that keeps track of the stored values. Right? So we use memoization. I just wanted to bring the point that if you want to use LuaJIT, you want, in this case. So you can say this is an inline statement, right? I just do something. So I just load the FFI, the foreign function interface, and I can decline, let's say, this function here from the math library, algamma, and then load it. And then note here that I have to use an untrusted version of PL Lua because I'm requiring some package, which is the FFI, right? And then now I can create an easier L factorial by just calling algamma n plus 1, let's say. They're perfectly equivalent. So some quick server-side examples. Just some quick server-side examples. If you want, you can, as I said, you can have plans, you can have cursors, and so on. So here's a quick example with this prepared statement. So you have an insert into values, and this $1 is a value that gets substituted. So the plan gets prepared, and this type here will be an integer. And then I execute it many times using I here. And I gets substituted every time in the table. So here's how it runs. So I can fill the factorial table with 4 entries. And then later on, I can update it by setting L in the factorial table to be just the L facts that we have created before, and then that's what you have. Here I'm selecting N, L, and an exponential of L so that you can see that they're factorials. Just a quick example. All right, so some quick take-home points. So by design, we know that Lua is easy to embed and extend. And it's fast, powerful, flexible, and portable. Again, I'm preaching to the core here, but it's really nice if you try to develop these interfaces, how easy it is to get this done and how quick. And I was just looking at the size of the code, and I looked at the Vim if Lua size. It was roughly about 1,500 lines to do all the interface for Vim, and it's pretty much feature complete. And I was looking at the Python one. It was like 6,000 lines. Because it has Python, Python 3, and then there's a huge include file and so on. So it's much, much smaller and easier. So Lua allows for a very tight integration. Again, we have native types. We don't have to do some string conversion tricks for either Vim or PostgreSQL. You can also use very rich semantics. We can borrow some semantics from Lua, but we try to be as close as possible to what's usually done. You don't have to follow just a straightforward, let's say, C library type of semantics where you have getters and setters. You can have very rich semantics. You can have modules, static modules as well. And the basic line is try to use Lua for fun and profit if you want. So with that, I'd like to thank you, and I'm open for questions.
Did you do any performance comparisons with something like PLPGSQL? For example, for a big table, update some tables with a procedure, things like that?
Not with PGSQL. I did with PL Python some time ago. And it was, for the applications that was basically running big text files and importing them into the database and then selecting some part of the text files. And Lua was about 5 to 10 times faster. I haven't tried LuaJIT. At that time, LuaJIT didn't exist. It was way faster.
So I've used Lua a little bit in the past, and one of the kind of oddities is that when you're defining a stored procedure, it's appending an end to construct the function, so that if you have some Lua code you want to execute at the time of compiling the chunk, you have to insert an end followed by a do, which will then be paired up with an end. And this is very strange. You know, can you think of any cleaner way to allow a different way to allow us to do this?
Well, I could think, yes. I could always think, but I think that the main motivation for having the and at the end, for doing it that way, is to allow the up value, that specific up value. I don't know what would be the trade-off between getting rid of the u and just having a straightforward where it always will compile to return function and then end at the end, right? But I don't know. You could always, depending on how it's done, because it's done this way, you can always finish with an end and then put a do, and then finish with an end and then put a do, and so on and so forth. Oh, I see. Well, let me go back to, so it's created this way, right? So it's kind of symmetric, but if you put a do, then it becomes unsymmetric. But I don't see how you can get rid of that. I mean, I think it's a price to pay, but I think that if you use the do, that should be somehow rare, right? It shouldn't be so common. I think it depends, but I don't see how you can get rid of it.
Well, I mean, maybe a preprocessor on the code. I've never looked at the actual implementation of how you do it, but I assume that you're just taking the string, appending the end, and then
it's exactly that.
Loading it.
You're right. It's exactly that. I mean, I just take that function, and then I look at the catalog of the database, and then I take the name, the argument, the types of the arguments, the names of the arguments, and then the return type. And then I just take the header as it is here, local u, and then the name of the function. And the name of the function equals function, and then the names of the arguments, and then I just append the function body, and then I append and return the name of the function.
And then load the string in.
It's exactly as it is here.
Oh, thank you.
I guess that's it. Thank you.